Hello and welcome to Geometry Lesson 1-2, which is over points, lines, and planes. Now this is basically the first topic that we can properly call geometry. It's going to be pretty heavy in vocab, so I think it's a fairly straightforward lesson, but it's a very important one because the vocab that you developed here today will be used throughout the course. This is where geometry is going to start from, and everything's going to kind of build from here. So you want to definitely make sure that you're focusing hard today, you're paying attention, and you're starting to get used to some vocabulary here. Okay, what vocabulary is there? Well, the main one is, of course, points, lines, and planes. However, there's also space, collinear, coplanar, and intersection. So we want to understand what all of these words are. Our goals today is to be able to identify points, lines, and planes. So to identify those types of geometric shapes, what they're represented by. We also want to be able to identify the intersection of lines and planes. So we want to be able to say, what does it look like when two lines intersect? And what does it look like when two planes intersect? Okay, so let's get started from the beginning here. Okay, in geometry, point, line, and plane are considered undefined terms because they're usually readily understood and are not formally explained by means of more basic words and concepts. Okay, so that just means that point, line, and plane, you don't need to have a bunch of other vocabulary words that help explain what they are. They just kind of explain themselves visually. You are already familiar with the terms point, line, and plane from algebra. You graphed on a coordinate plane, so that'd be like your graph, a piece of paper, 2D flat object, which we call a plane, and found ordered pairs that represent points on lines, right? So if you have the point 5, 4, you go over 5 on the x-axis, up 4, and you put a little dot there. That is a point. And if you make another point and you connect those 2 points together, you've made a line. Okay, so that's all we're talking about today: points, lines, and planes. You've done a lot of that. You've made points, you've connected them into lines, and you've had those written on a plane, on a piece of paper. In geometry, these terms have a similar meaning. Okay, so a point is a location. It has neither shape nor size. Okay, so in this, it's named by the capital letter A. So what does it mean by it has no shape? Well, it's not, if you zoom in on it, it's not a circle, it's not a little star, it's not a little square. It is dimensionless. So we draw a little circle because we want to mark where the point is, where the location is. But in reality, if you were to zoom in, you are not expecting to see like a little circle that gets bigger as you zoom in. The point is a location. So in the same sense that on a graph, you've got lines in the y direction and lines in the x direction, and you can place those points at a spot at an intersection of those two lines. What we're calling a point is really the intersection of those two lines. It's a location. It's not an object. Okay, so kind of try to keep that distinction clear. A point is a location. It is not an object. It is not a shape. Okay, a line is made up of points and has no thickness or width. There is exactly one line through any 2 points. So once again, when we're saying it has no thickness, obviously when you draw it on a piece of paper, that line has thickness. You can, get a microscope and you could say, how thick was that line? Did I push real hard on the pencil and make it real thick? Or did I write real lightly and make a thin little line? Okay, but that's not what we mean when we're defining the actual term line in geometry. We don't mean, excuse me, we don't mean an object that has a width of some sort. We're just talking about the space in between 2 points. So if you have 1 point up here and 1 point down here, the line is everything directly in between. Now that does not mean that that space directly in between needs to have some thickness in between, either thick or thin, but just the series of points, the series of locations that would occur between these two defined points. Okay. It's often named by letters representing 2 points on the line. So on this line, there are many, many, many points, but 2 points have been labeled, and that's how we're going to describe the line. We're going to call it PQ. Okay, so we can call it line M if you want to just give the line a name, or if you want to do it by the points, you could call it PQ. There's different ways you could write it. You could write PQ with these little arrows that are showing that we're talking about a line. You could just write the two letters next to each other, and usually that's understood as well. Or you could write the two letters in the opposite order, because it doesn't really matter if we're saying from P to Q or from Q to P. It's going to be the same line, no matter which direction we're thinking about. Okay, our final geometric kind of description is going to be a plane. A plane is a flat surface made up of points that extend infinitely in all directions. There is exactly one plane through any 3 points not on the same line. Okay, so there's exactly one plane through any 3 points that are not on the same line. So if you said there were we wanted to define 3 points on this pen, let's kind of treat this as a line. You could say 1 point at one end, 1 point at the other end, 1 point in the middle. So if they're in the same line, they're not necessarily in just one plane. So for example, I could hold a piece of paper, in this direction. Let's do like a little post-it note. I could hold a plane in this direction. Okay, those 3 points are kind of in that plane. They're along that plane. But I could also turn that plane, and they would still lie in all of these different orientations of a plane. Okay, so when it says there's exactly one plane through any 3 points not on the same line, what they mean is if you have 3 points on the same line, so 3 points on this line, then there are many, many, if not infinite, different planes. As you slowly rotate this, you get slowly different kind of planes pointing in different directions. Okay, and it fits them all. However, if you have 3 points and they're not on the same line, okay, something like this. Well, what can you make when you have 3 points and they're not on the same line? You can usually make a triangle, right? So draw a little triangle here. Okay, so these 3 points are only lying in the plane of the Post-it note. I can't take a different Post-it note and get it to go through all 3 points. The only way that I can get a plane to go through those 3 points is if it's oriented perfectly with them. Okay, so as long as they're not in a straight line, so 2 of them can be, but as long as all 3 of them are not in the same straight line, there's going to be exactly one plane that cuts through those 3 points. Okay, so let's say, how about we ignore this point right here, and we say we put another point up top out of this plane, right, up above it. Well, we'd have 1, 2, and this third one up here. You could make a triangle out of those 3. You could connect those 3, and then you would have, a plane in this direction that was containing those 3 points. Okay, so any 3 points that are not in a straight line will have exactly one plane that connects through them. That plane will contain a little triangle that has those 3 points. So if you look at this picture, the plane is labeled K. Those 3 points, like I said, could make a little triangle that lies in that plane. You imagine drawing a triangle on a sheet of paper. That's really all we're talking about. 3 points would lie on a flat piece of paper as long, and only a flat piece of paper that was in one direction, not any direction at all, but only in one given direction, depending on where you put those 3 points. Okay, so we can name it, similar to this, we can name it in kind of a few different ways. It doesn't matter how we list these 3 points, but if we list the 3 points, B, C, and D, in some order, or we just name the plane some letter by itself, we can do either way. So we can call it plane K because we've labeled the plane, or we can define it based off 3 points that we choose. So we could call it plane CDB, CDB, okay? Our last 3 vocab terms here. One of them is space, okay? So space meaning what you think it means. The space kind of like in between 2 objects. So if you had object A and object B, they exist in space. There's space between them. There's kind of a region of locations. Space is basically what So a plane is two-dimensional. Okay, it has length and width. But like if you thought of a coordinate plane, there's infinite little intersections. So a plane contains infinite, locations within it. Space is the same thing. It's just for 3 dimensions. So if you imagine like when we think of space, we think about basically everything outside the Earth, right? So the Earth is floating there in space. You have the Earth, you have Moon, they're both hanging out in some location in what we call space. So space is not typically thought of as a thing, it's a set of locations. So it's basically just saying, what are all of the possible locations that exist in 3 dimensions? What are all the places I can, put the end of my finger? Okay, there's a point here, there's a point here, there's a point closer to me, further than me. There's all of these dimensions of space that I can move through, and anywhere I move is a unique location. So space is just the set of all of those locations. However you want to, if you want to put a boundary over it, you could have a bounded space. But in general, we think of space as boundless, which just means you can go, that direction as long as you want. You can go this direction as far as you want. If you have a spaceship, you can go that direction as far as you want. Okay, space never runs out. We just keep going, which is its own very confusing and interesting idea, but it's we're not going to go there in today's lesson. What's at the edge of space? Maybe nothing. Maybe it goes on forever. Maybe it truly is boundless. Okay, so now we have collinear and coplanar. Co, like cooperate, means together. Okay, you've probably heard a lot of words that start with co, so we're talking about things that are together. So collinear are 2 points. Collinear points are points that lie on the same line. Non-collinear points do not lie on the same line. Okay, so they're together on the same line. A and B and C are all collinear to this line. A and E are not collinear to that line. However, you could make a line that went through A and E, and then you would say A and E are collinear on that line. Okay, so to say collinear, you have to define a certain line that you're talking about. It's not to say that you could make a line between 2 points. It's that you've already defined a line. Now, which points are on that line? Those points are collinear, together on the line. Okay, coplanar, very similar. Coplanar points are points that lie in the same plane. Non-coplanar points do not lie in the same plane. Okay, so if I put a bunch of dots on this Post-it note, all of those dots would be coplanar. They would be in the same little sheet, the same plane. If I made 4 dots on this paper and then I put a dot up here in space, well, those would not be coplanar, not all 5 of them anyways, because this point was not on the same plane. Like before, you could define different planes that might capture different sets of points, but for points to be coplanar, they must be on some defined plane. They must all exist on it together. Okay, can 3 points be both non-collinear and non-coplanar? Well, let's think about this little question here. This is an interesting question, so let's use our vocab. Can 3 points be both non-collinear? So non-collinear would have been like this, right? We have 2 points. We have 3 points, but they're not in a straight line. So that was our definition of non-collinear. That's the only way you get 3 points that don't make a line. Okay, now if you have 3 points that don't make a line, so that they're non-collinear, they're not on the same straight line, those 3 points are going to make a triangle. You're not going to be able to put you could put 2 points, those will be connected by a line no matter where you put them. But that third point, if it's not going to fall in the same straight line, then it's going to fall somewhere that allows you to draw a triangle. And that triangle will exist in some plane. So no, you can't have 3 points that are both non-collinear and non-coplanar. As long as you have 3 points and one of them is not on the same line, you've given the conditions to draw a triangle. Triangles can exist in 2D sheets on a piece of paper, on a plane. Okay, so the answer to this guy would be no. All right, so rewind that, review it, watch it as many times as you need to get more comfortable. Use Google, search up these vocab terms on Google Images to see some examples. You'll start feeling confident pretty quick on what these definitions are if you go about reinforcing it that way. Okay, let's move on to example 1.